In this video, I'm going to start introducing us to some concepts in object-oriented programming. I've already been talking about object-oriented programming throughout this video series. The sort of main concept for that is that we have classes, which are the descriptions of objects. So they have attributes and properties and fields and things like that. Then we have the methods in it, which contain the code and algorithms that process the data. And so that would be something that looks like this. So this would be a class that I'm just calling my class, and it would have these fields right here that we declare, and then it would have some kind of method, and you can have multiple methods in a class. And then instantiation is when we make instances of the class. So those are the objects. And that uses this syntax right here. But there are four other important concepts in object-oriented programming that I'm going to be discussing in this and in the next video. And so these four concepts are abstraction, encapsulation, inheritance, and polymorphism. In this video, I'm going to discuss inheritance and polymorphism. So this is one of those things where, it's kind of difficult to know like which of these things we want to talk about first because they all kind of interrelate with each other. So it's hard to talk about one just in isolation. But I decided that I would do inheritance and polymorphism first. And then in the next video, I will talk about abstraction and encapsulation. All right, so inheritance is, it sounds kind of like what it is. So we can make a class, and then we can have another class inherit the properties and the methods from that class. So over here, I have this kind of illustration here that shows that usually the way that you would do that is you would have a parent class here that would be sort of more general, so something like animal, and then you would have a more specific type of class that would inherit from it, so something like bird, because a bird is going to have all of the attributes that an animal has, but then it will also have sort of its own unique attributes. Another example that we see down here, a vehicle is something that has all these attributes, and then an SUV is a specific type of vehicle that will then have all of the attributes of a vehicle, but then its own attributes in addition to that. The attributes that make it an SUV type of vehicle. And so this kind of gets into like formal logic and stuff like that, which I do have videos discussing if you want to learn more about this idea of sort of the genera and the species going on here. But that's sort of what's going on here is you have these more abstract classes and then the more specific classes. And as we'll see in the next video, you can actually get very abstract classes that essentially just declare methods that don't have any body to them. But we'll get into that in the next video. And here is a somewhat more concrete example. So we could have our parent class here, which declares all of these fields right here, and then has its own method like this. Then the child class we would have down here. And so this child class, so this is the syntax you use for inheritance. So you declare the child class, then you do a colon, and then the parent class. And now this child class has all of the things that the parent class has sort of implied here. So you could use those, but then you can also declare its own unique things like this. So we could have the gas price, mileage, distance, then cost. And so we see that we're using car owner here, but this is something inherited from up here, but it is allowed for us to use it here because car owner and age have been inherited by this child class here. All right, so when setting up child classes, the inherited attributes and methods do not need to be redefined and re-implemented. So that's what I'm talking about here, where we can sort of use this car owner and age in the child class, even though they are not actually declared in the child class because they are inherited from the parent class. Uh, so we have single inheritance, so a class inherits the methods and attributes from one other class, and we can have one-to-many inheritance, where a single class can be inherited by multiple other classes. So in C sharp, C sharp doesn't allow for many to one. So you can't have like a single class that has inherited from multiple parent classes. So many to one is allowed in some other languages like Python and C++. But this runs into what can sometimes be called the diamond problem. So if the same method is inherited by two classes, so say A up here has a method that is then inherited by B and C on this diagram here, and then D inherits from both B and C. So which version of the method should D use? Should it be the B or the C version of the method? And so you can run into that problem if you allow this sort of many to one inheritance. But as we'll see in the next video, there is actually a way to do many to one inheritance in C sharp, and that is using interfaces. But we'll get into that in the next video. All right, so inheritance allows a programmer to derive a new class from an existing one. So the existing is called the parent super base class, as I've been talking about. The derived classes are called child or subclasses. The child inherits the characteristics of the parent, and the child has special rights to the parent's methods and data. So you can have the public access modifier and the protected access modifier. And so I will sort of briefly go through just a few of these access modifiers here. But so the child class can have its own unique behaviors and data, which is called polymorphism, which is what I'll discuss here next. So these access modifiers, sort of briefly, so we have public, private, protected, and internal. There are a few other ones that I will go over in more detail in the next video, but for now, so public, so any other class in the namespace can access and use classes, properties, or methods marked as public. Private can only be used in a class in which it was initialized. So it can't be used in the child classes. It can't be used in any parent classes that the class has inherited from, and it can't be used in non-related classes. Protected, so child classes can inherit the properties and methods marked as protected and can use them within the class. So they can't, so objects instantiated from these child classes won't be able to use them, but you can use them within the child class. But other unrelated classes cannot use anything marked as protected. Then we have internal, so anything in the same assembly, which is essentially just the same directory or folder, can use it. All right, so if we move on here to polymorphism, so we just discussed inheritance of these four important concepts in object-oriented programming. Now we will discuss polymorphism. So polymorphism is when multiple implementations of the same behavior. So polymorphism uses inherited methods to perform different tasks. So this allows us to perform a single action in different ways. And so these are the types of polymorphism. So the ones I'm going to talk about are method overloading and method overriding. And so these are known as static polymorphism and dynamic polymorphism. So those are the two types that I'm going to discuss. I won't be discussing operator overloading in this video. So we will start with method overriding. So this is dynamic polymorphism. So an object behaves in a different way depending on the context in which it's used. If you want some more about this, you can check out that link, which will be in the lecture notes linked to in the description down below. So in the parent class, we use the keyword virtual when declaring a method. Then in the child class, we use the keyword override with the method of the same name as in the parent class. And it also has to have the same return type. So we have here, so this is just kind of an example. So we could have public class animal. So this is just an animal class. Then we use the dog class, which inherits from the animal class. And so we have this this method here, which we're just calling eat. And so in the animal class, we declare it as virtual. Then in the dog class, we declare it as override. And so that will override the parent class version of this method, which is just a void method that just prints this out in this example. So when a method is overridden in the child class, you can use the base keyword to access the original method from the parent class. And so that would be something like this. So we have our dog class, which is inheriting from the animal class. We are doing public override eat. Then we just use base.eat, and this will print the original method up here from the animal class. So you cannot have the child class or unrelated class as reference pointing to the parent class object. So for instance, if we had this, so we have animal A1, so we're instantiating the animal class right here. Then we instantiate the dog class, and we have it pointing at this animal class. So the child class pointing at the parent class will throw an error. And so they're not like the same data type essentially. So the dog class data type is not the same as the animal class data type, and so you cannot have these sort of pointing at each other. And you can't do that with unrelated class as well. So if we instantiate this animal class, then we have car class, and we try to have that reference the same data here. This will also throw an error. So it's also the type of object being referenced, not the reference type, that determines which method is invoked. So if we have the animal method eat overridden by the dog method eat, if we use the eat method in different contexts, so using the different objects, so we're instantiating both the animal and the dog classes here, and then we use the animal one with eat. This will use the animal class version of the method. If we use the dog object here with eat, this will use the dog class version of the method. And so that's again, that these are not like the same data types essentially. These two classes are essentially of their own data type. All right, so dynamic polymorphism can also be done using abstract classes and interfaces, which again I will talk about in the next video. And so that was method overriding. So we're overriding the methods that we inherit from the parent class, but we also have method overloading, not just method, but also constructor. And so this is a polymorphism in C#, where multiple methods with the same name but with different arguments in type or number. So the method overloading would look like this. So we're using the same name for the method, but with different number or type of parameters. They do have to have the same return type, but they can differ in the parameters that you are inputting into the method. And so if we have this method here in a class, so we have int and bool here, we could within the same class we could make another method with the same name, but now we change the parameters. And so in this one we just change the order of the parameters here. So instead of int bool, we have bool int. Then in this one, we just change the parameter data type. So instead of int and bool, we have just, say, two float types here. We can also have different number of parameter data types. So we have int and int for the first one and bool for the second one, but now we are adding a third parameter here that makes this a different method right here. Again, it has to have the same return type, but it can have these different number of parameters. And then we can, it's the same thing for constructor overloading. So we're just changing either the order of the parameters, the type of parameters, or the number of parameters. And these become different constructors. And so that is method or constructor overloading. So then we will look at this a little bit more concretely here in code. So I just already have this written out, so you don't have to watch me type all this out, but I have some of the main method here commented out so we can sort of go through this bit by bit. And so what I have here is a parent class, which is right here. And so I just called it parent class. So we see that this has declared some fields here. Then we have this, which is actually using this getter and setter, which I'm going to discuss more in the next video, but for our purposes, what we have here, so I declared this car owner here as internal, and so that can be used by anything sort of saved in the same file. But I declared this one as protected, this license suspended here. And so then what I'm doing right here, so I'm making a public ls here. Then this ls is actually giving us access to this license suspended right here. So that's what this get and set is. So the get is giving us read access to license suspended, and the set is giving us write access to the license suspended. And so using both of these like this with return license suspended, so when I use this ls property right here, it will actually give me the license suspended value, whatever value the license suspended has taken. Then the set is just giving the license suspended the value of whatever I give ls. And so when you use get and set like this is essentially like making the license suspended field here public, because this will just return the license suspended or set the value of the license suspended, which is, the two things you can do with it. We'll see in the next video that there are more things you can do with get and set, but I just wanted to sort of introduce us to this idea of the getter and setter. And like I said, when you use it like this, where you're giving both read and write access like this without making any changes to it, this is essentially just making license suspended public if we sort of do it through this ls property here. All right, so then I have these two methods here, and we see that these are the same name method, so I'm overloading this method. So this one has a parameter int, and this is a parameter bool type, and so this method is overloaded here. And so we are taking this age as the input parameter, and then it just sets the age field from up here equal to whatever that input parameter is. Then we have if age is greater than or equal to 21, then drinking age, that's the name of the method, will return true. Otherwise, it will return false. And this one down here is just using adult. So adult we have up here as a bool type. So it's either true that you're an adult or false that you are an adult. And so if adult equals true, and so that will return true. It's just saying yes, they're an adult. Otherwise, it will be false. And so another thing to notice up here. So here I'm using the parameter in this if statement. Here I'm using the this field up here in the if statement. So you can use either one. So I could change this to age right there, and that would still work because we're just setting age equal to this parameter. But now the age here will be that the input age that we input into this method here. And so we could just use either one of those. And so I have two child classes here. So we'll look at the first one first. So this is the child class 1 here. And so we are using this syntax here to inherit from the parent class up here. And so all fields, properties, and methods from the parent class are inherited. But then we can declare these new fields right here for our child class. And then we also have this new method here. So this method is not inherited from the parent class. And so we are making our own method here. But what you can see is I'm using this car owner and license suspended here, which are things that were inherited from this parent class. So I can use these fields that were inherited from the parent class, even though I have not declared them here in the child class. And so I can use those in here. Then with the second child class, so I am actually using these methods that were inherited from the parent class, so drinking age up here. But what we see here, so I'm doing two of them, so I'm both overriding and overloading it. So these are overloaded since I have the same thing here, but this one I am overriding. So I'm overriding this from the parent class, and this one I am overloading. So this one I'm also using the base class, the base keyword here. So this one will, even though I overrode it, I'm also using the base, so it will just use the one that was inherited here, and it will use the inherited one that uses the integers. So remember, we had this one that was integer up here, and so it will know to use that one since I am declaring the integer one here and overriding that one. Then we have this one here, and I have this different parameter type right here, which is actually the child class 1. So this will use child class 1 data type as the input here. And again, I'm also using the age and adult here. And so what I have down here in the main method, so I have made a child class 1 object. So I've instantiated that, and I've put in some of these parameters here. So these ones right here were inherited from the parent class, and then these were the 3 ones up here that I made new in the child class. So this child class here can still use these inherited fields right here. Then this is just using this method that I called cost. So this cost right here, and I'm inputting these 3 parameters right there. So the gas price, the mileage, and the distance, and then I can run this program. And so what you'll see here too is I have this with toString, and then I have this in the argument of toString. And so this is going to be a float type, which is a decimal type. And this in the argument of the toString method will tell the program to use only 2 places after the decimal point rather than using all of the places after the decimal point. And so running this, I get this. And so Allison's gas cost for the week is $5.26. And so it took these 3 numbers here that I used. And so you see I put this F here after the decimal point. And so that tells it that is just the number of places after the decimal point. It's the number of significant figures after the decimal point for a float type here. That's what that F means. And so it just used this right here. So this this math right here. So gas price times distance times 5 divided by mileage. So you see this will end up being money times gallons. So, the money spent per gallon. And so that is what that is doing. So when we run that, it gives us the price here of gas for the week. All right, so then we can look at a few of these other ones. So I have some more using child class 1. So I've instantiated some different things using child class 1 here. So we can uncomment these out and look at it. So this one is just child class 1 for Bob here. And so we can put in the different fields here. And then I have another one for Chad Chaddington here, and we can look at what happens with those when we run this here. So for Alice Allison, we still have this. For Chad Chaddington, I have that their license is suspended. So this is that LS here. So remember, the LS is that property up here that just is the getter and setter for license suspended. And so down here, I'm just saying that chad.ls is equal to true. And so that gives us that the license is suspended, and so no driving. And so Chad Chaddington's gas cost will be $0. Oops. Let's re-maximize this here. But yeah, that is using that child class 1. Then down here, I'm using the child class 2, so I'll uncomment that out. And so this is just, so I'm instantiating the child class 2, and then I'm using the child class 2 method drinking age for Alice, Bob, and Chad. And so those are all child class 1 data types. And so it will use this method right here because that takes child class 1 data types as input. And so then it will look at their age and whether they're an adult here and output different things based on that. And so if I close this and run the program again, so now it's using this. So we have Alice Allison is 38 years old and so is of legal drinking age. Bobby Boberson is 17 and so is not of legal drinking age. Chad Chaddington is 55 and so is of legal drinking age. And so that's just running this code right here. So taking in the age and adult status, and so running this is of legal drinking age if they're true, and if either one of them is false, then they are not of legal drinking age. And so we had Alice be age 38, an adult, true. Chad Chaddington was 55, an adult, true. Then Bobby Boberson was 17, and we still said that was adult equals true. And so just being 17, even if adult is equal to true, will trigger that this is the code that will run here. But anyway, those are the things I wanted to discuss here about the inheritance and then the polymorphism. So remember, inheritance is just the fact that we have this parent class and then these two child classes are inheriting all of these things from the parent class, but then can sort of declare their own new things in addition to what they have inherited. So that is the inheritance. And then the polymorphism is the overriding and the overloading. So we have here this overloading where we are just using the different parameter data types here with methods of the same name here. So that is overloading. Then overriding is what we have going on sort of down here where we have this override going on. But then we can override it and then still use the base keyword here, base dot the name of the method here to use that method. And so we could do that, but we could also have other stuff going on here. So we could put other stuff in here, but then still use whatever we have in the parent class. So we can have other stuff going on here. We could add new functionality to this method here and then still use whatever functionality we had up here in the parent class. And so that is polymorphism there. But anyway, I hope you found this video helpful, and I will see you in the next one.